This one? Okay. So hands up anybody who's heard of George Washington Carver. No hands. I hadn't heard of him either until a few years ago. George Washington Carver was an incredible, influential agricultural scientist. But his life didn't start out very well. He was born in the 1860s in the USA. He was born into slavery, which is a pretty depressing start for a story, and I'm afraid it gets worse. He was born into slavery. When he was only 1 week old, he was stolen by raiders. Sad. He was recovered. His mother wasn't recovered, and his father had died before he was born. So he was a slave, and he was orphaned at 1 week old. So that's a bit of a downer. But the good news is it gets better from here. He went on, he got his education. He became the first African American to earn a BSc. And then from then, he achieved even more things, and he made these incredible contributions to agriculture. And because of that, he became the first person who wasn't a president to receive a national monument. And he had a ship named after him. There's the SS George Washington Carver that was named after him. And he was an incredible inventor. So he was inducted into the Inventors Hall of Fame. So what did George Washington Carver do to get all these amazing honors? Well, the story is he invented peanut butter. So why is this even interesting? Why would anybody get so much recognition for peanut butter, and why are peanuts interesting? It has to do with what was happening in the United States at that time. In the south of the US, the dominant industry was cotton farming, cotton plantations. And most of the land there was taken up by cotton, and there was sort of a bit of a Wild Western expansion. So owners would sort of come in and they would build a plantation, and they would farm it for about 10 or 15 years, and then they'd move on. But why were they abandoning the farms? Well, it turns out cotton is an incredibly, incredibly hungry crop. And you can grow cotton for about 10 years, but then after that you can't grow it or anything else anymore. It exhausts the soil. So what they've been doing of farming for 10 years and then moving on, you can do that for a while, but it doesn't scale. At some point you run out of land. And then that meant that there was this problem that the whole of the south of the United States was all of a sudden agriculturally barren. And there were people who, newly liberated slaves after emancipation, who were trying to farm this land, but they couldn't because it was exhausted. And normally what you might say in that kind of scenario is, oh, it's okay, just go out and buy some expensive fertilizers and then everything will be okay. But of course, if you're starving, you can't afford fertilizer. You can't afford anything. And so we ended up in this vicious cycle where the soil was hungry, the people were hungry, the animals were hungry, and nobody could figure out how to help. And this is where George Washington Carver came in. Who here gardens? One or two hands. Either those who garden or those who don't. Do you know what peas do for the soil? Peas almost uniquely fix nitrogen. So they take nitrogen from the air and they're able to transfer it to the soil. So they're able to enrich the soil. They're able to almost provide their own fertilizer. And so that's true for just a few kinds of plants. Peas, soybeans, sweet potatoes, I think, and also peanuts, because weirdly a peanut isn't a nut despite the name. It's a bean. So all of a sudden we have a solution to this problem, because cotton exhausts the soil, but beans and peas and peanuts can restore it. So what George Washington Carver realized is that if you took your land and you divided it in two, half you would have growing cotton, half you'd have growing peanuts. But then you'd rotate it. So the next year, you'd swap them round, and then the next year, you'd swap them back. And so there was these, all of a sudden, the farmers were getting much better cotton yields than they'd been able to get before. But there was a problem, because half the time, farmers were growing peanuts. At the time, peanuts were barely considered edible. Peanuts were not considered a crop that anybody would bother to grow. And these farmers were coming up with piles and piles of peanuts, and they were going, oh, what do we do with all these peanuts? We don't want them, peanuts. And so the other innovation, the first innovation from George Washington Carver was he realized that this system of crop rotation would give you much more than you put in. But then the second thing that he realized is that, you know what? Peanuts are tasty, and peanuts are nutritious. And since you're starving, why don't you eat these peanuts that you've just grown? So he came up with all sorts of ways to make peanuts appealing. So peanut butter, salted peanuts, chocolate-covered peanuts, all of these things that we now just take for granted and assume people always ate peanuts these ways are actually really quite new. And Carver came up with a lot of these. He wrote a book called 101 Uses for the Peanut. So now we have this excellent situation where the land is restored, cotton yields are fantastic, and everybody who had been starving has all of this food. The food is all peanuts, but peanuts are tasty, so it's okay. And I love this story because I love this idea of the double win. I've become a bit obsessed with the double win. It seems so magical that you could solve one problem and then almost by accident solve a second problem as well. And so I keep trying to come up with the right words for it. So I call it the double win, but I'm not sure that quite works. Sometimes it's called win-win, so we have a win-win situation. You could call it win squared to show that the wins are kind of multiplying in this amazing way. Or you could say 1 + 1 = 3. But then if you say that, you have to add a lot of context to explain what you mean. Otherwise, people just think you really shouldn't do math. You can call it a twofer, but I think maybe that only works to people who sort of know that phrase. Someone suggested I should call it the Überwinden. And I really like this because it sounds really cool. And it sort of implies, that you definitely know a really technical term and that, there's a lot of Uber in there, so it's good. The only problem with this one is if you don't speak German, like me, it sounds really cool. I think if you speak German, it means something completely different. And then you just go, what? Or sometimes I've experimented with calling it the extra win. None of these are just quite right, so I'll stick to the double win, and hopefully you know what I mean. And we see this kind of double win all over, and it's so cool. I want to give another example, which is it used to be when you went shopping, you would have a basket, and you would go around the shop, and you would buy your things. But baskets, if you put tins in, if you put potatoes in, they get pretty heavy. And they're kind of annoying and they're awkward. And then, eventually you're kind of there in the shop like that. And an American shopkeeper had this idea that seems so obvious now, but wasn't obvious at the time. What if you put wheels on the shopping cart? Then all of a sudden, it's really easy to go around the shop. And people went to his shop because it was so much more comfortable shopping there. So he got the win. But then he got the double win because what he found was people were buying way more. Because normally, if you only have a basket, you're kind of limited by what you can carry. if you have a huge trolley, you can buy way more. So again, he got this double win. And a lot of these great innovations, I think, start with taking something that everybody knows and realizing it's not true. So for George Washington Carver, everybody knew peanuts were barely edible. You wouldn't even feed them to your animals. And he realized, no, actually, peanuts are really nice. And I want to tell another sort of similar story from my experience. I work for Red Hat. I'm on the team, I'm an engineer, I help build Quarkus. But until recently, I worked for IBM. And I've done a lot of different things in IBM. Most recently, I worked in IBM corporate strategy, and my job title was innovation leader. I can tell you, if you want to get a lot of requests on LinkedIn, change your job title to be innovation leader. It's like a magnet on LinkedIn. I think I got asked to do a talk in a gym. I was like, why? I don't know, but they thought they wanted an innovation leader to come talk at their gymnasium. So I didn't do that one. But before I was an innovation leader, I was a consultant in the IBM Garage, who were a consultancy team. And what we did there was we worked with businesses to help them innovate. And we worked with huge businesses, tiny little startups, everything in between. But before I did that, I worked on the team building what became OpenJ9. At the time, it was IBM J9. And I was a performance engineer. And I used to spend a lot of time talking to people about Java performance. And people would say, it's so annoying that my JVM has to do all this just-in-time compilation. And it's so annoying that it has to do all this garbage collection. And why can't it do all of these things ahead of time? And I had to say, you don't understand. If you do just-in-time compilation ahead of time, what ends up your program will actually be slower than if you do the just-in-time compilation. And so even though it seems like just-in-time compilation is a cost, you get these speed-ups. That was true 15 years ago. Now, things are different. So now, everybody knows that programs go fastest if you let the runtime optimizers do their thing. And my job is to explain, actually, doing things ahead of time will end up being faster than doing it dynamically at runtime. And this is true for the JVM itself, but it's also true for the whole application. So everybody knows reflection is a good idea, right? No, I think nobody ever really thought reflection was a good idea. Reflection was just useful. But in the sort of the before cloud world, applications were really dynamic, and they could do a lot of cool things by being so dynamic and changing. But in the cloud world, the containers are immutable. The containers do not change, and so there's no point having a dynamic runtime in a static, unchanging environment. It's just a waste. So one of the innovative leaps that the Quarkus team were able to make is to say, if we start by making something that works really well with GraalVM, that can compile to native, those same techniques we use for that will actually make the application work better in the cloud. And they'll even make the application work better when it's just running on the JVM without any native compilation. And so as a result of that innovative leap, we have Quarkus, which starts really fast, and also the throughput is pretty amazing, so it runs really fast. So that's cool. That's the win. But then we come to the second win. We come to the double win, which is that the developer experience for Quarkus is is joyful. They talk about developer joy. And because you're doing all of this stuff ahead of time, you can get rid of a whole bunch of boilerplate code. So there you get the double win. And actually, for Quarkus, I can't tell if that's the double win or the triple win. I sort of lose count. But then you definitely do go on to the triple win, because one of the things I'm looking at the moment is trying to measure how much carbon you can save by running on Quarkus. And it's about 2 or 3 times less carbon if you run your application on Quarkus. So again, and it's better to program and it's faster. So that's all kind of amazing. But I think what this sort of shows is that sometimes these good ideas, they arrive and they're in the right place at the right time. And they now seem kind of like, of course you would do that. But at the time that they were first thought of, they seemed really stupid because everybody knew things didn't work like that. But of course, if the best ideas seem stupid when they were invented, does that mean every stupid idea is going to turn out to be a best idea? No, it doesn't. But some ideas that seem stupid really weren't. There's lots of examples of these. Cheeseburgers seemed really stupid when they were invented because people thought you shouldn't put cheese on a hamburger. I don't even understand how that seems stupid, but there it is. Laptops seemed stupid when they were invented. And I want to talk through this whole quote because it's just so amazing. This was in 1985, so not that long ago. And the New York Times said, "People don't want to lug a computer with them to the beach or on a train to while away hours they would rather spend reading the newspaper." Here they mean like a physical newspaper, not the one on your phone, but like one that you actually turn the pages. Somehow, the microcomputer industry has assumed that everyone would love to have a keyboard grafted on as an extension of their fingers. It is just not so. So hands up who's walked down the street holding a phone, right? Yeah, and hands up who feels anxious if your phone is more than about 5 feet away from you. Yeah, so we sort of, we thought that we wanted computers to be compartmentalized, and actually it was the opposite. We wanted computers everywhere. So thinking about the double win, I think laptops, they're an amazing technology. I don't think they're really a double win. I think they're just kind of a single win. But I mentioned some ideas seem stupid and turn out to be sensible. Some ideas seem stupid and turned out to just be stupid. And this is something that George Washington Carver also had a lot of experience of, despite being an amazing inventor. Among his ideas for what you could do with peanuts were peanut bread. It was not a success. Peanut sausage, not a success. Although maybe 150 years later, I think we're starting to see more nut-based sausages, so maybe he was just 150 years ahead of his time. Peanut coffee, never a good idea. I don't care how far in the future you go, peanut coffee is not going to be a good idea. Peanut-based paint, not a good idea. But my favorite, peanut nitroglycerin. So for those of you who don't know what nitroglycerin is, nitroglycerin is TNT. It's explosives. So, and I just want to repeat how bad an idea making explosives out of peanuts is. And George Washington Carver, he was lucky. He worked at a university, and nobody said when he came up with the idea of peanut bread and peanut-based nitroglycerin, "You're fired," because he did have that security to be able to come up with bad ideas mixed in with the good ideas. And this is really important, this idea of psychological safety, this idea that you can do things and you can get things wrong, and it's okay. And it's really, really important, if you're innovating, that you have to have failed experiments in there. Because every time you have a failed experiment, what you're actually doing is learning. And learning is really important. And so often we see organizations that talk a good talk about innovation. But there's an expectation that every innovation is going to succeed. And to really be doing it well, you have to have an organization where you go and you say, let me tell you about my latest innovation. Yeah, it didn't work. And you know the other one, the really, yeah, that didn't work either. And you know the amazing one, the coolest idea, yeah, that didn't work either. And the reason it's good to have all of these failures, the reason it's good to have all of these crosses on the whiteboard, is because it means you're asking questions that you didn't already know the answer to. But of course, you don't want all failure, and you don't want to be investing too much in ideas that turn out to be really bad ideas. So how do you tell the difference between something that seems kind of ridiculous and it's almost impossible and stupid, and something that's actually impossible and stupid? I think you all know the answer to this. The answer is that you have to build something small, and then you have to iterate. You have to make incremental improvements as you learn. And this can feel kind of weird, because sometimes the thing that you take out in order to really optimize for feedback is something that you would normally do, and it might even be something that you would normally do first. So the story for the shoe company Zappos is that when they started, everybody knew you could sell books online if you were Amazon, because at the time Amazon only sold books. But you couldn't sell something like shoes online, because that was ridiculous. That was stupid. Everybody knows people need to try shoes on in a physical shop. And he had this idea that maybe you could sell shoes online. But he knew it was kind of an impossible and stupid idea. So what he did was he set up a front end. He set up something that looked like a shoe store. It had photographs of the shoes. But then when someone would buy a shoe, what he'd do is he'd take their order and he'd go out to his local shoe shop and he'd actually buy the shoes, probably at a big loss, and then send them out. And this meant every time he sold a pair of shoes, he made a loss. But every time he sold a pair of shoes, he knew that his idea was working. And so then once he'd lost enough money, he invested in building the back end, he invested in building the procurement facilities and the warehouses and all of those really expensive things. And we did a similar thing in the IBM garage. We worked with a company who sold construction equipment. And the way they did it was they were selling to the contractors. It was completely sort of by phone. So a contractor would say, oh, I need a joist. So they'd ring up their representative and say, can I have 6 joists and can I have it by Tuesday? And they wanted to digitize it because it was 2020. But they weren't sure if the contractors even wanted to order their equipment that way. So what we did was we did the sort of somewhat standard development process. So we did the visual designs, then we showed them to users and said, do you like this? And they said, oh, yes, I really like it. And then we did our DevOps, so we put in place our CI/CD pipelines, and then we started building. So we did a responsive web app, and because I'm a huge advocate of TDD, so we did TDD at the same time as we were building. And then we deployed the whole thing to production and let people start using it. But there's one thing that you may notice is missing from this. And that's the order processing system. When someone would click the button on the website, what it would do is it would send an email to the seller to say, hey, Bob Contractor really wants 6 joists. And this was kind of annoying, but it was no worse than how they were processing the orders already. And so it meant we could see whether people actually wanted to buy things in this way. And this is called a Wizard of Oz MVP. So it's something that, from the front, looks like the real deal. And then if you look behind the curtain, you realize actually there's 2 hamsters frantically pedaling to make the whole thing work and someone processing emails to send things out. And this can feel really uncomfortable to do, because I think all of us, we want to do things properly. And as well, we want to get it right the first time. But usually the reason we want to get it right the first time is because we know we may only get one chance. If we're going to be able to release often, if we can release every week, that makes us much more able to do incremental improvement. And as well, if we don't have to get everything into the first feature, because once the first release is done, that's it. Again, that makes us much more able to do incremental things, which makes us much more able to learn, which is where innovation comes from. But when you do this kind of incremental adjustment, you do have to have some way of knowing, am I on the right track? Are people actually liking this? So you need to have some sort of metrics in place. And this is something that a lot of organizations are getting really behind now. Hands up who's had an email within their company saying we're going to be data-driven now. Lots of us, right? I think I had one last week. Being data-driven is the new thing. But being data-driven, it seems like a good idea in theory, but it doesn't guarantee success. There's a fallacy called the quantitative fallacy, which is also called the McNamara fallacy. And it says that if you have numbers, it looks like you must know what you're talking about. And so if you show numbers to someone, it doesn't matter what the numbers say, they're more likely to believe you. So I do encourage you on your CVs and in your internal presentations, put as many numbers in as you can. So on your CV, increase productivity by 6%. It's better than increase productivity a lot. But the problem with numbers is often we stop at having the numbers. And we don't really think about, well, what do these numbers mean? How do I know? What does a number have to be for me to think I'm doing a good job? If I increase productivity by 6%, is that a fail or is that a win? And it's really worth thinking about this ahead of time. Another problem with being data-driven is when you have a double win. Almost always with the double win, the second win is a surprise. You tried to solve one problem, and hey, isn't it amazing? We solved this other problem as well. And so if you weren't expecting it, you probably don't have metrics in place. And so it could be that you do like average on your first win, and the second win you didn't have the metrics in place for. So that can be a problem. And of course, measurement is expensive. So one of the things I sometimes ask is how hard should we try to measure? How much effort should we put into gathering these metrics? So like we're doing that at the moment with Quarkus. We know lots of people like Quarkus, but we don't know how many people. And so then we're sort of trying to do better metrics for like, how many people are actually using us? But how much effort you should put into your metrics, a lot depends on how confident you are to begin with and what your environment is like. If you're in an environment of high uncertainty, if you don't have a clue and it might change tomorrow, you need to be doing experiments. You need to come up with your hypothesis. And the key thing about that hypothesis is it's something that's able to fail. It's not, I am awesome. No matter what the numbers say, I am awesome. It has to be something where there's two answers and one of them shows that you got it wrong. And a hypothesis your experiment has to be designed to fail. You have to try and disprove yourself. That's the scientific part of it. And so to be able to disprove something, you do need those really strong metrics. And then that allows you to learn. With your learning, you can then go on and you can do your follow-on experiment. If you're in an environment of moderate uncertainty, then you should still be really incremental. You should still try and get as much of your scope out as possible before you do your first release. But you're really hoping your first release is going to work. You're not trying to fail. You're not trying to prove yourself wrong to prove yourself right. You're just trying to prove yourself right. And then once you've done that first release and hopefully proved that there's some value somewhere, then you can go on and you can just sort of iterate continuously to expand your scope gently, gently, gently. And of course, those two are connected. Once you've done enough experiments, then you can go to your environment of moderate uncertainty. And this is something that a lot of organizations like to do. A lot of organizations that take innovation seriously will have something that they usually call an innovation funnel. And the idea, which makes a lot of sense, is that we only have limited resources. We can't invest in everything, but we want to have lots of ideas. Let's prune out the bad ideas early so we can focus on the ideas that are going to win. What could possibly go wrong? Well, a few things. So the idea, the theory, is that you have lots of ideas coming in at the idea stage, and then you narrow them down until at production you only have a small number of ideas that you're sure are going to win. Unfortunately, what often happens is that instead you get the innovation railroad. And this happens when it's not okay to say, I had a bad idea. You say, I have an idea and I'm going to get that idea to production because otherwise when I write my annual assessment, I'm going to look like a failure. But of course, just because you push it through to production doesn't mean it's a good idea. It just means that you're deferring the failure and the horrible thing happens at production rather than being discovered earlier on. Another thing that I sometimes see is the innovation fizzle, where lots of ideas are generated, and then they all get to a certain point, but then somehow none of them actually get to production. Nothing leaves the innovation team. And the innovation railroad often happens if you have that lack of psychological safety. If you can't say, this was a terrible idea, we should stop. And the innovation fizzle often happens when you have an isolated, siloed innovation team. And their idea is to come up with ideas and build a prototype, and no one's figured out how to get that prototype into the rest of the organization. But even the innovation funnel isn't guaranteed to work well because it can end up with a lot of bureaucracy. And the whole thing of putting in innovation applications and then proving that it's going to succeed and going through the gates, it can start to become a lot like work. And there's often, I think, just sort of too much effort and too much seriousness in this. And one of the side effects of this as well is we get something that I call the phonovation, which is where there's too much incentive to innovate, but not enough real desire to fix problems. And often this happens because an organization will have an innovation budget, but they don't have enough slack in their normal budget. So the innovation budget ends up sort of doing weird things. And so the people who are sort of keeping the lights on for the business are exhausted, and they're in this exhausted soil just trying to make things work. And then there's the innovation team, and they've got foosball tables and ping pong tables and snacks, and they're in a separate building, and they just come up with ideas, and then nothing ever happens to the ideas. And I saw this a lot in the IBM garage, and I saw a lot of people chasing the shiny thing without really thinking about what problem they were trying to solve, or without realizing that they could solve that problem maybe in a different way. So 2017 was the year of the chatbot. Every single person who came through the IBM garage said, we need a chatbot. And so we'd say, okay, why do you need a chatbot? And the answer was usually, sometimes it was because we need to reset passwords, which was a bad answer. But often the answer was because our internal search is so bad that no one can find things, and we're hoping a chatbot will help. A chatbot will not help unless you fix your internal search first. So you could just fix your internal search and skip the chatbot, and you'd be just as happy. 2018 was the year of blockchain. Everybody who came through said, we need blockchain. We'd say, why? What problem do you need to solve with blockchain? They'd say, because our processes need to be digitized. We'd say, you can digitize your processes without putting it all on a blockchain. For many processes, you're going to be better off that way. People didn't always listen. And I think what these were is they were just sort of normal improvements. Things like we need to digitize, things like we need to fix our internal search because it's terrible. But they knew that if they went to the board and say, we need to fix our internal search, the board would be like, boring. So instead, they'd say, we're going to do a chatbot to be innovative. And then hidden inside that chatbot was the thing they really wanted to do, which was fix the internal search. And I used to get really frustrated with this. I used to think, couldn't you just say what you want? But actually, I got a bit more chill with it. Because I think what was happening was that this disruptive technology was enabling something that was really good. And maybe it was actually kind of okay to abuse innovation in this way. And so maybe the Trojan horse, I think it makes it seem like really negative, like something terrible is going to happen if you let the Trojan horse in. But actually, I think maybe it's more like a sheep in wolf's clothing. It looks really scary. It looks like this risky innovation. But then actually, when you get closer, you realize it's just a cuddly sheep that's going to make you a jumper. And sometimes, in the best world, we would never have to disguise anything. But sometimes, just like a present, a disguise is okay, and a disguise makes things nice. But of course, even though I'm less angry about this pattern than I used to be, you should still think, if this is happening, why is this happening? Do we need to have a better focus on the right metrics and solving the right problems? And with a lot of those things, I mentioned that the innovation funnel can have so much bureaucracy, and it just gets a bit boring. So instead of innovation being joyful and amazing, and hey, this is so cool, it's just like, I filled in my 6-page explanation explaining why my innovation cannot fail. It's just like, really? Couldn't it be a bit more exciting? And going back to this idea of the double win, I think it works for people too. Because all of us, you do the same thing every day and you have deadlines, and the daily grind exhausts teams. They get burnt out. But if you let them play, it restores them. They get, a sparkle in their eye. They have ideas. And play is really important. Play has a lot of business value. In general, the most intelligent mammals are the ones that spend the most time playing when they're young. So the ones that just sort of come out of their mum and stand up and go off and start eating, they don't tend to do much except eat the rest of their life. Whereas the ones like the monkeys and the dolphins and the humans and the elephants, the ones that play, end up being really clever. And they end up being able to adapt to different circumstances. And if you look at one of the differences between people and robots, people play. People love play. Robots can't play. And I think that's partly why why automation can't handle surprises, is because it's that play is the sort of the elasticity that allows us to be resilient. And play, amazing things can happen from play. So many products, when you go and you hear the origin story of the product, it starts, our founder was on a plane and he had 8 hours with no one bothering him. So he decided to just see what would happen and then it turns into this really incredible product. And so we need more of this. We need more elasticity. We need more slack in our system, and we need more joy in our normal work, because that's what allows us to find the innovations that are going to change the world. But of course, you can't play all the time. There has to be some work in there, because otherwise the lights wouldn't stay on. But I think George Washington Carver's ideas work really well for this too. So what he said is that you rotate your crops. Year one, you have cotton and peas, and you have the peas and the cotton, and then you have the cotton and the peas, and then you have the peas and the cotton. And why this works is for soil and for people. A change is as good as a rest. So in our teams, we can do something like, first week, one team's, doing the daily grind, and then the rest are playing, and then they swap, and then they swap, and then they swap. You probably wouldn't want to do it 50% of the time. 50% of your people are playing. But it can be really healthy to have some kind of rotation. So for example, in Red Hat, one of the things that we do that is our business model is we support open source products. In order to make them supportable, we have to do a whole bunch of stuff. We have to dig into the provenance of every artifact in it. We have to make sure that we can rebuild it. We have to sort of do all sorts of tagging and stuff. And it is really manual, really expensive. And I don't think it's the most enjoyable IT job out there. So what we do is we try and rotate people in and out of that team, because we know if people stay in that team for too long, it's a bit miserable. And when new people come into that team, they bring new ideas. So rotations can be a really good way of doing things. Another pattern that we see a lot is 10% time. So an organization will say, every Friday afternoon, you can do what you want. You can do a cool side project. A lot of Google products like Google Mail famously came out of this kind of 10% time. The problem with 10% time is it tends to fall apart if you have deadlines. So you know that in theory you could do Friday afternoon on your cool side project, but you have this deadline and you have too much to do, and how's this going to work? And so often it sort of ends up being something that's written in the hiring thing of like, we have 10% time, but then it actually doesn't happen in practice. Another model that I've seen that I really, really like is having an iteration off. So I used to work on WebSphere, and it was back when we did big, infrequent releases. And they were hard. You don't want to miss the train for the release, so everybody would be pushing and working evenings and working weekends, and you just end up in this big sort of ball of pressure and horribleness and pizza trying to make the deadline. And then when we finally made the deadline and we shipped WebSphere, everybody would be like, oh. And so sometimes management would say, you can have time off, which was nice. But sometimes what they said instead was even nicer. They would say, you still have to come to work, even though you worked so hard. And that sounds horrible. But they would say, you have to come to work, but we're not doing any project management. We're shutting Jira down. We're canceling all the meetings. You can spend the next sprint working on whatever you want. And some of our best features, some of the features that the developers liked best, came from those play iterations, those free time iterations. And I think the reason that works in a way 10% time doesn't is that everyone was off at the same time. It wasn't like some people were trying to do things and some people weren't. The whole team had a sprint off. The other advantage this has over something like a hackathon is that hackathons tend to happen at the weekend, whereas this happened in working hours. But, whether it's 10% time or whether it's that kind of iteration off, it's easy to say, be more playful, have more slack in the system, but it isn't easy, especially in organizations that have financial targets and that are trying to prove that they're well run, because play has consequences. When your people are off playing, that's lost productivity. That's things that they aren't doing. Although actually, I don't think it is lost productivity. I think it's untracked productivity, which is not at all the same thing. But as well, I said that some of our best WebSphere features came out of those play sprints. But not everything that came out of those play sprints became an amazing feature. Some of them were just failures. And you have to be okay with failure, because no matter what you do, some innovations are going to end up being an even worse idea than peanut nitroglycerin. So if you take just a few things away, I would really encourage you to try and embrace play, because it will bring happiness and innovation. So it's the double win. Do be iterative. Iterate as tightly as you can and get those optimized for feedback loops so that you can see what's going on before you've invested a lot. And to make that work, you have to measure, but be cautious how you measure. Be cautious not to fall into the quantitative trap. And no matter what you're doing, look for that double win. If you can find that double win and solve two problems at once, you're going to solve two problems at once, which is kind of amazing. So with that, I'll stop and we can go on to the rest of the conference. The slides are there. Please do enjoy the rest of the conference. Happy to have questions after in the coffee break, and thank you very much.